Let's practice using the simple steps for symmetry on two basic functions, the first of which is f at x is equal to x squared. So we know that this is just a basic parabola. Step 1 says to find what f at negative x is and compare that to f at x. So if we sub in negative x on the left side, then we better do it on the right side. Squaring a negative is really a positive, so we can change this negative x squared to just x squared. Now you can see that this function and this function are the same. So f at negative x is equal to f at x. Therefore, the function is even. This makes a lot of sense if you look at the graph of x squared, which of course is a basic parabola. You can see that it's symmetrical in the y-axis, or that the portion on the right side has a reflected image in the left side, and the mirror would be right here on the y-axis. Now let's consider the function f at x is equal to x cubed, which of course is a cubic function. First we'll check if the function's even, so f at negative x is equal to negative x cubed. But this time we're cubing a negative number, so it's not going to change to a positive, it's going to stay a negative. So we get negative x cubed. You can see that f at x and f at negative x are not equivalent expressions, so therefore this isn't even. Step 2 says to move on and see if it's odd, so we're going to find what negative f at x is. Negative f at x means just simply take the original function and multiply it by a negative. That's going to give us negative x cubed. Now look at f at negative x and look at negative f at x. Those are equivalent expressions. They're the exact same. They're negative x cubed. Since they're the same, the function's odd. So I'll write it out. F at negative x is equal to negative f at x. Therefore, the function is odd. Let's also look at the graph of x cubed. So the cubic function looks like this. We say that an odd function is symmetrical in the origin. This means that its reflected image mirrors across the y-axis and then across the x-axis. Let's try using the steps for a slightly different function and maybe a little bit more difficult. Let's try it for h at x is equal to x times the square root of 2 minus x squared. Okay, so the first step says to find what h at negative x is. H at negative x is equal to, I sub in a negative x here, and I sub in a negative x in for the x squared. Out here, I get a negative x, and on the inside of the square root, the negative x squared will become a positive, so I'll be left with 2 minus x squared. So if I look and compare h at x and h at negative x, you can see that h at x is not equal to h at negative x. So therefore it's not even. Now if I move on to step 2 and I figure out what negative h at x is, that means to take the original function and multiply it by a negative. So I get negative bracket x times the square root of 2 minus x squared. Now this is just one term on the inside, so this negative doesn't distribute to each thing, it distributes just to the front here. So negative x square root of 2 minus x squared. And you can see that the h at negative x function and the negative h at x function, so these two, are the same. So h at negative x is equal to negative h at x. So, therefore, the function is odd.